All right, we're going to look at 7.1 quadratic functions and applications. What I would recommend, because there's a lot of information in this section, and you should do this each time, is look at all the problems. If you can kind of click through and kind of see what information you're going to be asked to answer, it will give you an idea of what to focus on. So you can kind of go through each and every problem. Once you go through every problem, spend a little bit of time in the ebook. Okay, so the textbook will give you definitions, examples, and show you terms, and even does a great job of showing you visuals, and it has a lot of information in it. But this is going over quadratic functions. It's a parabola, U-shape. You can see the axis of symmetry. It has it labeled because we're going to be trying to identify the axis of symmetry, the vertex. I'm doing this from standard form and from vertex form. So down here you have a standard form. You also have vertex form, where you have this a times x minus h squared plus k. This is done by completing the square when you have standard form. It goes over the process of knowing whether the parabola opens up or down, labeling the vertex, finding the minimum value or the maximum value. And so there's a lot of great information, so I want to encourage you to kind of spend some time going through it. It does exactly what we're going to be doing in the homework, showing you a sample problem. These are some of the problems that you saw in the beginning, and it goes over the solution of answering each and every one of those parts. So for the most part, I'm going to be focusing on showing you how to do it in the section, but it would be important for you to at least go through this, take some notes, and then of course it's also interactive. Like you can click these links and it'll take you directly to that learning objective in the online textbook. All right, let me see. That was something that was interesting. No. So I thought there was a new form of finding the vertex when you have standard form listed in this book, but it just goes over the traditional method, which is plugging it in. But I can potentially show you another method that I saw in a different textbook in case you want to know. All right, well, let's get started. So number one has 9 parts. We are given a function. It is in vertex form, so we can see the vertex HK, and we're going to determine whether the parabola opens up or down. Okay, so let's talk about this right now. So I have this function g of x, and we have negative x plus 3 squared plus 1. So the leading term, which is a, will tell you if it opens up or down. If a is positive, it goes up. If a is negative, it opens down. So we can see that we got a negative out front. So I know that this graph is going to open downward. It says identify the vertex. So the vertex is this minimum point. Now, in the standard form, it gives you a x minus h plus k. Now, if you notice, the sign is opposite. You're always going to do the opposite sign. The fact that we see a positive 3 means that we plug a negative 3 in. Okay, so minus a negative will give you a positive. So that tells me that h value is negative 3. The k value is positive, is still positive, so that sign is the same. That value is going to be 1. Your vertex is given by that ordered pair, opposite sign, same sign. So vertex is negative 3, 1. Good. Okay, now it wants us to determine the x-intercepts. So to find the x-intercepts, we're going to have to set it equal to 0 and solve for x. if I go to solve this, if I subtract 1, and then I can divide by -1 to get rid of the negative. Give me 1 equals this expression. We take the square root to get rid of the square. Square root of 1 is 1. Should be considering plus or minus 1 when you do a square root of a number. And then that's going to have us having x plus 3. So we have plus or minus 1 equals x plus 3. So we will subtract 3. So that will give us -3 plus or minus 1 equals x. So if we do -3 plus 1, gives us a -2, and -3 minus 1 gives me a -4. So these two values will give me my x-intercepts. Y value would be 0, so ordered pairs will be -2, 0, and -4, 0. Next part, determine the y-intercept. Okay. So y-intercept we would get by plugging in a 0 for x, okay, in solving. So if I take my original function, plug in a 0 for x, which is going to be a 0 here. Basically, we get 0 plus 3, which is 3. We square 3, gives us a 9. So this will be a -9 plus 1, which gives us 8. And so my y-intercept would be 0 for x, +8. Something. Oh, I'm sorry, wrong sign. -9 plus 1 was going to give me a -8. Gotta be careful with that sign. Okay, -8. All right. The next part wants us to sketch the function. So one of the easiest things to do is we're going to plot some of these points we've already found. So we're going to plot the vertex, -3, 1. -3, +1, yep. So we're going to go left 3, 1, 2, 3, up 1. And we're going to plot the x-intercepts. So the x-intercepts would be -4, 0, and -2, 0. Okay. So 3 points will be good enough. Plot the vertex, up and down, and then put it on one other point, and so it'll draw it for you, and then we just check. So we're good there. Determine the axis of symmetry. Now the nice thing about vertex form is it gives you the axis of symmetry. That's the x value of the vertex, so -3, and we always write it as an equation. So the axis of symmetry, which I'm going to abbreviate AOS, axis of symmetry, x equals whatever that x value of the vertex is. So x equals -3. It's just an imaginary line that cuts this graph right down the middle. It's symmetric. So we're going to say x equals -3. And next we want to determine if we have a minimum or maximum. Okay, so if you look at this graph, it opens down. Anytime it opens down, you have a maximum, a high point, and all the other points are lower than that. So we will have a maximum the value of that maximum is the same as the y coordinate of the vertex. So we have a maximum of 1. Okay, so the maximum value of G is 1 in this case. And then the last part, what is the domain and range? So this is just a standard parabola. The domain is always all real for general parabola. So we're going to say from negative infinity to positive infinity. Your range, however, is dependent on your minimum or maximum value. So my range, it goes down to negative infinity, but it only comes up to a height of a y value of positive 1. And we will include that 1. So we'll have a parenthesis and a bracket, negative infinity up to 1. Now, I do want to point out that in our Blackboard course, we do have some handouts in the video sections, parent functions, and it does show you some of these properties. So when we're doing quadratic, you can see the domain is all real. The range for this parent function is 0 to infinity. If it was opening down, it would be from negative infinity to whatever the high point is. So you do have that in our course as well to use.